Hello, everybody. So, today we're going to do the hardness of water lab, where we're going to measure how much dissolved calcium and magnesium there is in water. Okay, so first of all, we're going to start out with tap water. So we're going to take 15 milliliters of tap water, and so in this case, we're just going to titrate it. I have the tap water inside of the graduated cylinder, but I'm going to measure it with the pipette just because it's more accurate. And so in this case, it's a 10 milliliter pipette as specified in the experimental details. And so we're going to add in one addition of 10 milliliters, and then we're going to go back and we're going to get another 5 milliliters to make it up to 15 milliliters of tap water. Okay, so remember, when you're using pipettes like this that are made out of glass, be very careful. One of our most common lab accidents is somebody is pushing down too hard on glass pipettes and they snap them off and stab themselves. So whenever using glass pipettes, be very careful. Make sure that you do not put them under pressure. All right, so once you have your 15 milliliters of your sample, in this case tap water, we're then going to have to treat that because we want to keep the pH constant. Okay, so if we want to keep our pH constant, we're going to have to add a buffer. And so in this case, this is our pH 10 buffer that is specified in the lab procedure. And they also want you to use a 1 milliliter graduated pipette to add this one. And they want 5 milliliters in total. So that means 5 additions of 1 milliliter apiece. And so again, this is going to be more accurate than just using your graduated cylinder for 5 milliliters straight. A little bit more tedious, but more accurate. Okay, so in this case, we're going to take our buffer, we're going to add 5 milliliters, and now our pH is going to be set at 10. So we aren't going to change that by any of our additions. We will have a fixed pH, as we talked about when we did buffers. Okay, so at this point, we can finally start talking about some of the stuff that we're adding to actually detect calcium and magnesium that's going into the solution. Because right now we just have water, and that water is at pH 10. So what we're going to use to grab onto calcium and magnesium is our EDTA solution, this big molecule that grabs onto metals. And so we're going to add a little bit to start with for our titration of the tap water. It requests that we add half a milliliter to start, and then we're going to add our indicator. And so this is going to tell us when we have actually grabbed onto all of the calcium and all of the magnesium. So as long as there's some of it that isn't bound to the EDTA, this solution is going to stay kind of a pinkish reddish. But once we've covered all of our actual sample and we've gotten enough EDTA to reach the equivalence point, we will turn blue. Okay, so this is what the solution kind of starts out with. It's kind of a pinkish purplish sort of color. And then we add in our EDTA solution. And as we add it, it's going to start turning more bluish. And so in this case, it didn't take very much extra. I was almost at the equivalence point already when I started filming, but so pink to blue. And so now we know exactly how much EDTA we added to get to that blue point, and that's going to be our equivalence point of our titration. So we know how much EDTA there is added, and that should be equal to the calcium and magnesium that are in the solution. Okay, so this was repeated twice. We've got the data here. So we started out with 15 milliliters of tap water. We added the specified amount of the EDTA, and this is the total amount that's listed on this table, and then you go from there. So second titration, we're now going to use an unknown water solution. In this case, we're going to use Fiji brand bottled water because they have lots of dissolved solids in it. Okay, so notice, not for human consumption. We do not drink things in the lab. Okay, so this case, we're going to start out with just 10 milliliters of our water solution. And so just one addition of the 10 milliliter graduated pipette. And so we got our 10 milliliters of water. Now we're going to do the same thing again, and we're going to add our 5 milliliters of our pH 10 buffer. And so again, this is going to take forever, and we're going to just add 1 milliliter at a time as we go. And so we're doing the same treatment to this. So again, it's now fixed. We've got an amount of water in there that's got calcium and magnesium. We have our buffer to make sure that the pH doesn't change. And then we're going to do the exact same stuff as before. We're going to add in a little bit of starting EDTA in this case to make the titration go a little bit faster. And then we're going to hit it with the indicator. And so then we're finally going to titrate. But first we got to make sure that all of our prep's set up. So carefully adding all of our buffer to make sure that things are fixed pH, which is always the slow part, is getting everything set. Okay, so then we get everything in there. Now we move on to our initial addition of the EDTA so that we have a little bit of a starting point so we don't have to add entire pipettes full at a time. And so we won't do this on the second set of titrations, just the first one. But so now we're going to add our indicator. It once again is going to change color. And once we've got our indicator all set and we're nice and kind of pinkish, purplish, now we're going to add our EDTA until it turns blue. So in this case, the Fiji water is much harder, so it's much more reddish. And so we have to titrate for a while to make sure that it gets to where we want it to go. And so in this case, I did not film until we got all the way to the end point because it was taking a while. But so we keep adding, keep stirring, keep adding, keep stirring, and you can see that it starts to change color from that original reddish to more of a purplish. And that's kind of where we're going to get for our titration endpoint on this one. You could go a little bit farther, but this is about where we want to be. So we get our data for our Fiji water. And so in this case, the total amount of EDTA added is listed in the table along with our 10 milliliter starting volume of Fiji water. And so we average out our two titrations again just to get an average number and hopefully a more accurate number from what it is. All right, so that's the first part. So now we're going to repeat both of these titrations again, but this time instead of using the buffer, we're going to use sodium hydroxide and we're going to make it pH over 12. So make it very basic. And we're going to use a different indicator, this Calcon indicator, that will only detect one of our ions along the way. So we're going to repeat again, and this time we're going to do it looking for just the calcium. So magnesium is not in the solution because magnesium precipitated out at pH 12. It went away from, it's not interacting with our EDTA anymore. So here's the data for the titration of tap water. And so our total amount of volume added and all the rest. And so then we move on and we do the same with our Fiji water. So then Fiji water, we have 10 milliliters starting again, and we have a total volume of 0.62 milliliters or 0.49. So a little bit more of a variance on this one, but we're going to take the average and go from there. If it was real lab, we might have gone for another round, but then we go from that. So using this data, calculate for the answers in the quiz.